Imagine a future where we communicate instantly despite distances that span light years. This is not some far-fetched science fiction dream, but a potential reality, thanks to a fascinating quantum phenomenon known as quantum entanglement. In the realm of quantum physics, two particles can become entangled. This means that the state of one particle immediately influences the state of the other, no matter how far apart they are. It's as if these particles are eternally linked, playing a cosmic game of Simon Says across the vast expanse of the universe. To put it in simpler terms, imagine you have a pair of magic dice. You roll one die here on Earth, and its twin, somewhere out there in the furthest reaches of space, simultaneously lands on the same number. This is quantum entanglement at work, a seemingly instantaneous connection defying the vast distances of space. Contrast this with our current methods of communication, which are limited by the speed of light. Messages sent to Mars, for example, take anywhere from 4 to 24 minutes to arrive, depending on our respective positions in orbit. This delay, known in scientific parlance as latency, can pose significant challenges, especially in time-sensitive or emergency situations. Now imagine if we could eliminate this delay. Imagine if we could harness the power of quantum entanglement for communication. We could send and receive information instantly, regardless of the distance. This could revolutionize not just space exploration, but also our understanding of the universe. However, as with any leap in science and technology, there are challenges to overcome. Quantum entanglement is a delicate phenomenon, easily disrupted by the environment. Harnessing it for practical use, especially in the harsh conditions of space, is no easy feat. But the potential rewards are immense. We stand at the threshold of a new era in space communication, where distances that once seemed insurmountable may no longer pose a barrier. The potential of quantum entanglement could make our current communication methods look like two cans connected by a string. This is the quantum leap in space communication that awaits us. According to the renowned physicist Brian Greene, entanglement is a strange feature of quantum physics, the science of the very small. So, let's take a closer look at this strange yet fascinating feature. Quantum entanglement is a physical phenomenon that occurs when pairs or groups of particles interact in ways such that the quantum state of each particle cannot be described independently of the state of the others, even when the particles are separated by a large distance. It's like two particles becoming so closely linked that they share the same existence. Now imagine a pair of entangled particles. If we change the state of one, the other changes instantly, no matter how far apart they are. This is not because of any physical interaction or signal passing between them, but it's as if the two particles are connected by a mysterious link. The idea of quantum entanglement was so strange that even Albert Einstein had his doubts, dubbing it spooky action at a distance. However, numerous experiments have confirmed that this spooky action is real and is a fundamental aspect of the quantum world. But why is this revolutionary? Well, it's because quantum entanglement challenges our understanding of the universe and the laws of physics as we know them. It defies the speed of light limit, as the information seems to travel instantaneously from one particle to another, regardless of the distance. Moreover, it allows for a level of synchronization that's impossible in classical physics. This synchronization could potentially revolutionize fields like computing and communication, especially in space where distances are vast and speed is of the essence. In essence, quantum entanglement opens up a world of possibilities. It's like having a secret, instantaneous communication channel that could connect different corners of the universe, a concept that's not just revolutionary but also mind-boggling. So, as we delve deeper into the quantum realm, we're not just exploring the science of the very small, we're also pushing the boundaries of our understanding and challenging our perceptions of reality. As Albert Einstein once described it, it's spooky action at a distance. And indeed, it's this spooky action that might just hold the key to the future of space communication. So how does quantum entanglement affect space communication? Let's hear it from Dr. Seth Lloyd, a pioneer in quantum computing. Quantum entanglement is a phenomenon that has the potential to revolutionize our understanding of space communication. This is not just a theoretical concept, but a tangible reality that could change the way we interact with the cosmos. Imagine a pair of entangled particles separated by vast distances. Despite the space between, these particles remain connected, their states reflecting one another in real time. This instantaneous connection, irrespective of the distance, is the magic of quantum entanglement. So, how does this relate to space communication? Well, communication as we know it is bound by the speed of light. Even using our most advanced technology, it takes considerable time for messages to travel from Earth to Mars, for instance. But if we could harness the power of quantum entanglement, we could theoretically achieve instantaneous communication no matter the distance. Dr. Seth Lloyd, a pioneer in quantum computing, has described this potential. He says, quantum communication could provide a kind of telepathy. No matter how far apart two people are, they could communicate as if they were right next to each other. The implications of this are enormous. Space explorations could become more efficient and safer. Astronauts on Mars could communicate with mission control on Earth in real time, making decisions quicker and addressing emergencies faster. It could even open up possibilities for communication with distant galaxies, an idea that was once the stuff of science fiction. But it's not just about space exploration. The potential applications of quantum communication are limitless. It could revolutionize our global communication networks, making them faster, more efficient, and more secure. It could change the way we understand and interact with the world and the universe. In the words of Dr. Lloyd, quantum communication could be truly instantaneous. A world where time and distance are no longer barriers to communication. That's the promise of quantum entanglement in space communication. But harnessing quantum entanglement is not without its challenges. As physicist Anton Zeilinger puts it, quantum entanglement is a very delicate state. Indeed, the delicacy of quantum entanglement is a challenge in itself. The entangled particles, or qubits, are extremely sensitive to their environment. Any slight disturbance can disrupt the entanglement, leading to a phenomenon known as quantum decoherence. This means that maintaining a stable, entangled state over long distances is a significant hurdle. The technical challenge of creating and maintaining entanglement is another roadblock. Currently, our ability to generate and control entangled particles is limited and requires extremely precise and sophisticated technology. This isn't something you can just whip up in a backyard lab. Now let's talk about the elephant in the room. Quantum entanglement doesn't allow for faster-than-light communication. It's a common misconception that entanglement could be used for instantaneous communication across vast distances. But the reality is that any information transferred via entanglement still needs a classical communication channel to be understood, which is limited by the speed of light. There's also the challenge of scalability. Sure, we've managed to entangle a few particles in a lab, but can we scale this up to a level where it's applicable for practical use in space communication? The jury's still out on that one. And finally, there's the issue of measurement. In the quantum world, merely observing a particle can change its state. This means that ensuring the integrity of the information being sent via these entangled particles is a massive challenge. In spite of all these challenges, scientists and researchers around the globe are tirelessly working toward harnessing the power of quantum entanglement. They're driven by the potential it holds, the potential to revolutionize space communication and bring about a new era of understanding and exploration. While the challenges are significant, the potential rewards are truly out of this world. The science of the very small could have a very big impact on our future. As we peer into the realm of quantum physics, we find ourselves at the threshold of a new era. An era where the strange and fascinating phenomenon of quantum entanglement is not just a subject of scientific curiosity, but a potent tool that could revolutionize space communication. Imagine a future where information can be transmitted across the vast expanse of space, not at the speed of light, but instantaneously. Quantum entanglement could make this a reality. Two entangled particles, no matter how far apart, can share information instantaneously. This could lead to a new form of space communication, where messages are transmitted faster and more securely than ever before. But the potential of quantum physics goes beyond communication. Quantum technology could also play a critical role in space exploration. With the development of quantum computers, we could solve complex problems and make calculations at a speed that is currently unimaginable. This could be instrumental in designing more efficient spacecraft, predicting weather patterns on distant planets, and even unraveling the mysteries of black holes. Even more exciting is the possibility of a quantum internet. A network based on quantum entanglement could offer unparalleled security and efficiency. This could revolutionize not just space communication, but all forms of digital communication, making our networks faster, more secure, and more efficient. But, as with any revolutionary technology, there are challenges to overcome. We are still in the early stages of understanding and harnessing quantum entanglement. There's much more to learn, and many technical hurdles to clear. But the potential is undeniable. As we continue our journey into the quantum realm, we stand at the edge of a new frontier. A frontier where the rules of classical physics give way to the strange and wondrous world of quantum mechanics. A world that promises to reshape our future in ways we can only begin to imagine. Stay tuned for our next video where we will delve deeper into the world of quantum computers and their potential role in space exploration.